Joining us in the studio now is Eddie Dombrower, president of Mirage Graphics, and next to Eddie is Rich Hilleman. Rich is with Electronic Arts. We've got an Amiga 1000 joining us, and Gary, we're going to see two neat games now, Earl Weaver Baseball and Ferrari Formula One. Okay, Eddie, how do these games differ from what traditional simulation? We've seen lots of baseball games and racing car games. What is different about this?
Well, the fundamental difference that we have in both of these games is that we use physical models of the real world, so that all the action happens in the place of the real world, and every now and then we update the screen so that you know what's happening in the real world.
Okay, what's an example of what you see?
Well, for example, in the real world, the ball falls at 32 feet per second squared, and when the hit is calculated, we calculate the trajectory of the ball, so if it's going to be a home run, it has to go up at a certain velocity so that it will fall behind the fence.
Eddie, in terms of the strategy here, it's called Earl Weaver Baseball. Did he actually play a role in developing this?
He played a very large role. He met with us about 5 times. We spent a lot of time with him talking about strategies, about the plays that he uses, both offensively and defensively, the way that he picks his lineups, the way he picks his rosters. All those things, he spent an awful lot of time playing the game and evaluating and giving us feedback on things that we've done and giving us some new ideas himself.
Yeah, well, let's take a look at it.
Okay. Well, we're in the bottom of the 8th inning here in a game between the American League All-Stars in the beginning of the century against the National League All-Stars 61-75. Earl's managing this team, which is the National League, and I'm managing this team here. Babe Ruth is up, and the tying run is on third base, and it's represented by Tris Speaker. He's not a very fast runner, so I'm going to bring in Sam Crawford. But first, I'm going to look at his statistics. We have over 40 stats per player, and this determines how he does in the field, on the base paths, and of course at bat versus left and right-handed pitchers. Okay, so we saw the lineups of all the players. Now we're looking at the stats of any particular player. That's right. And then you can go to the actual game. That's right. So I'm going to pick up Crawford and put him on speaker, and then change his position to center field so that my defense is set up here. And then I can pull people in and out of the bullpen, but now we're ready to go back into the game. Woo. Okay, now what field are we in? Now we're looking at the Polo Grounds. You can play in any ballpark, either real or fictional. You can design your own. It's one of the important things about using the physics models. It doesn't limit you to certain configurations of ballparks, so we can have that giant green monster in Fenway. What I'm looking at here is my options of plays that I can call on the offense. But I've got my base runners on. I'm ready to go. So let's see what Babe Ruth can do against Sandy Koufax. Because we've got a kind of close-up on the right there of the pitcher in the bag. So close-up, there's the pitch. He struck him out. Okay. So between innings, we get a television transition. You might explain, you're in what you call a one-pitch mode right now, so we're not really seeing a lot of pitches. That's right. We do this so that you can very quickly go through a game. We also have a mode where you can see every single pitch. And it takes 3 hours. That's right. It can. So now we also have an instant replay feature in this case, Earl comes out to argue. So we can see what he's arguing about here. Okay, so because his runner was thrown out at first. Right. Okay. So here's the instant replay. It's a slow motion replay. We can also freeze frame in the replay so we can see the seams spin on the ball on the pitch. So we'll see here that as the pitcher comes to the plate, we can really see the seams go there. So there's the hit. Okay, we're going to see if he was really out at first base or not, huh? It's going to be close. Ooh, a tough call. What did he call him, safe? Called him out. It looks safe to me. Here comes Earl, because he agrees with you. Eddie, now the action in the baseball game is really determined by the particular facts of that situation, isn't it? That's right. The statistics of each player, his ratings, the wind conditions, whether or not we're on AstroTurf or natural turf, where the fences are, all those things affect the outcome of each individual play and therefore each individual game. Everything's rolled up with a random number and everything's different every time. Must be a heck of a programming job, actually. Also, let me ask you about the digitized sound. We heard a lot of those sounds. What role does that play in the game? Well, we tried to make it as much like a TV experience watching baseball as possible, and sounds are a major part of that. And Terry Mason did an outstanding job of integrating the crowd sound effects and the umpire, which are digitized sound effects, as is the backcrack, with the announcer's voice, which is phonemes generated by the Amiga. It's tough to get those names to be pronounced correctly. It's realistic. Huh? Yeah, that's an impressive game. I want to turn now to you, Rich, and talk about Ferrari Formula One. Tell us about the development of that.
Okay, Ferrari Formula One was designed from the beginning to be a Grand Prix simulation as opposed to a racing game. So we spent a great deal of time finding out about the Ferrari F186 that was used in the 1986 World Championship season and finding out about each one of those individual tracks and the drivers that performed on the circuit that year. One of the things that we did was realize that at least a portion of the part of Grand Prix racing is the engineering and setting up of the car for each one of those individual tracks.
Okay, Gary, show us how you do that on this. That's pretty impressive.
Okay. This is the paddock screen, which is a menu system that we use to get you from different places. For instance, here you can see the Brazilian flag. You can see that there's a sun, which means that the weather is currently sunny and that the current selection has it set for a 2-lap race. Around the track is the garage, the transports, which allow you to get to other tracks, race control, which allows you to control the simulation, and the pits. And I have some final setup to do before we go do this race, so let's go straight here.
You can push on any of those things, click on any of those things, and then
it creates another reaction. Okay. So what I'm going to do is, because I'm not quite sure how to set up for here, I'm going to ask for advice from Morrow, who's a built-in computer crew chief.
Okay, so there are all the choices you have in setting up your car.
Right. What I can do is, this is the engine system requester, fuel injection ROM, oiling system, the turbocharger, etc. This is the tire requester, which allows me to select between different compounds and different tread designs. Wing settings, which are important for aerodynamics and maximum downforce, and suspension settings. Also on the screen is a race scoring monitor that's exactly modeled after the Longines Olivetti system that's used in Formula One racing. So I think we should just go out and get into this race.
Okay, now in this particular demo you're going to show us, the computer's really driving the car, right?
But when you drive the car, you drive it using the mouse, using the right button is the accelerator, the left button is the brake.
The first thing you see is what look to be real rear view mirrors.
Right. Those rear view mirrors are showing you exactly what's behind you, which in this case is unfortunate because there's nobody behind you. You are in 8th place. That guy was unkindly cutting in front of us. The dash you see in front of you is an exact copy of the dash that was on the F186. The top display is the turbo boost. The bottom display is the RPMs. I'm going to crank up my turbo boost so we catch up here. There's a gear shifter that you see is working there. The steering wheel moves, the front wheels move. The object of this game is a little different than most driving games in that your role isn't just to win one race, it's to win the entire season. That means you have to survive to finish the season. So you have to be careful and conservative and not destroy yourself.
And you can crash and get in trouble here like you could in
exactly.
the real race too.
If you were to run into the back of one of these cars at the proper speed, it could knock you out for anything from 1 day to the entire season.
Rich, we're kind of going for a ride here. It's sort of on autopilot. Is there some degree of randomness in there? We'll get a different ride each time?
Well, Rick Koenig, when he built the physics model and wrote the rest of the program, we did some data analysis on real-world drivers and discovered kind of the factor of error that they had. So we built that into both this AI opponent as well as the other AI opponents. Those other AI opponents are designed to be similar to the top finishers of the season.
Rich, Eddie, thank you very much. I know what I'll be doing this weekend now. Thanks for joining us. We'll be back next week with another look at games for the Macintosh and the IBM PC, so join us then.